Okay, so I thought I'd give you a little video to go over the homework questions that I asked you to do for tomorrow. Because now tomorrow will be the test, and I'd like to be able to move on Friday. So today I'd like you to do the questions on page 640, and then watch this video so that you'll know if you got them right or not. Okay, because I won't redo them on Friday in class. This is going over them now. So in question number 6, it says you have a proton attached to the surface, and you're going to put another one up here above it. And it wants you to find out what must be maybe it doesn't say, yeah, it is a proton. And it wants to know how far up it needs to be above the first one on the surface in order for this guy to be just floating here. Well, if he's floating here, it means the sum of the forces on him must be 0. And what are the forces on him? Well, there's an Fg acting down and an Fq acting up. So if we do sum of the forces, and it'll be in the y direction, is equal to may. He's floating, so that must be 0. So it'll be Fq minus Fg equals 0. So in other words, kqq over r squared must be equal to mg. And then you're just looking for r. So take the r squared up, bring the mg down. Kqq over mg must be equal to r squared. And now we can fill in our numbers. So we have r squared is equal to 9 times 10 to the 9th Newton meter squared per coulomb squared. It's a proton, so we know the charge of a proton. I told you the other day, it's on your sheet, 1.602 times 10 to the minus 19 coulombs. And there's 2 of them multiplied together, so that's like putting squared there. And then on the bottom is m, and I gave you the mass of the proton the other day as well, 1.673 times 10 to the minus 27 kilograms. And that gets multiplied by g, 9.81 meters per second squared. So if you don't know where I got these two numbers, go back to the first sheet of notes I gave you in this unit, and it's in the very top, the info on a proton and an electron, and it tells you the mass of the proton and the charge on the proton. So now you just punch your numbers in. Remember, the first number you get will be r squared, and it'll be 0.01407, etc. meters squared. Take the square root and get 0.11863 meters. Done. See, that wasn't too bad, was it? All right, so now let's move on to question number 7. Question number 7, you have 3 charges on the corners of a triangle, and it gives you the locations in Cartesian coordinates. So that's just like x, y. So it says that A has Cartesian coordinates 0, 4. So 0 means 0 in the x, 4 in the y. And it says the coordinates are in meters. So really this is saying this is 4 meters. It says B is at the origin, 0, 0. And it says C is at coordinates 5, 0. So 5 in the x, 0 in the y. And that means this is 5 meters. We can find the hypotenuse, because it's 4 squared plus 5 squared, so 41. And then take the square root. And I'm just going to leave it as square root 41, because I know in a few minutes I'm going to put it under kqq over r squared, and I'm going to square that root 41 and get 41 back. We can also find the angle, because we're going to need it. So opposite over adjacent, take the inverse tan of 0.8, and it's 38.66 degrees when you get the angle. Okay, so now this question's a little painful because it wants the net force on each charge. So in the example that we did in class, we did the net force on one of them, but now it's asking for the net force on each. So before we start to do the net force on any of them, we should find the individual forces. So we need to find FQAC, and that's going to be KQA over r squared. So it's going to be 9 times 10 to the 9th Newton meter squared per coulomb squared. A was 5 microcoulombs, so 5 times 10 to the negative 6. C was 4 microcoulombs, so 4 times 10 to the negative 6. And the distance between them is that root 41 meters, and that's going to get squared. When you punch that in, you get an FQAC of 1.40625 times 10 to the negative 2 meters. And it is going to be... Oh, I did the wrong one. I just punched in B, not C. C is going to be not that. I did the right numbers, I just looked at my wrong answer. AC is going to be 4.39 times 10 to the negative 3 newtons. That's better, not negative. Okay, FQ... let's do AB next. I don't know why I started with AC. Let's do FQAB, which was what I was thinking I was doing when I was writing the answer down. So it'll be KQAQB over R squared. So it'll be 9 times 10 to the 9th Newton meter squared per coulomb squared. 5 times 10 to the negative 6 coulombs. And this time B is minus 5 times 10 to the negative 6 coulombs. And the distance between A and B is 4 meters squared. And this time you get FQAB to equal negative 0.0140625, or if you want in scientific notation, negative 1.40625 to the negative 2. And that's newtons. Whoops, not that you could see because I just went off the page. And then you have to do the last one, FQBC, and it's going to be KQBQC over R squared. So 9 times 10 to the 9th Newton meter squared per coulomb squared. B is negative 5 times 10 to the negative 6. C is 4 times 10 to the negative 6, and they are 5 meters apart, and of course you have to square that. And so you get an FQBC of negative 7.2 times 10 to the negative 3 newtons. Okay, so now with these three guys, we can now find the net force on the three charges. Okay? So let's start on charge A. So we need to go back to our diagram and we say, okay, so first A. So here's my A. What is B doing to A? Well, B is negative, A is positive, so B is going to be attracting it. It's going to be pulling it down. So this will be FQAB, and we already have that value over here. What is C doing to A? Well, C is positive and A is positive, so C is going to be repelling. So C is going to be pushing it away up like this. Okay? So this is going to be FQAC, and it is the 4.39 times 10 to the negative 3 newtons. And I'm writing that there because we're going to have to break it into its components. So this will be FQACX, and this will be FQACY. Okay? And this angle here is the same as this angle here. So this is 38.66. So we can find the X and Y. If we start with the X, the FQACX is just the adjacent side, so it's going to be cosine. So it's going to be FQAC cos of theta. So it's going to be 4.39 times 10 to the negative 3 newtons cos of that 38.66. And when you punch this in your calculator, you get FQACX to equal 3.428 times 10 to the negative 3 newtons. Okay, so that's my FQACX. If I do my FQACY, it's going to be sine, so 4.39 times 10 to the